So we are looking to make sense of this process here. Now, you'll remember that the whole reason we have to come up with new interpretations is because when we initially introduce multiplication, if we talk about 3 times 5, we have 3 groups of 5 objects. And there isn't really a good way to make sense of 1/4 of a group of 3 objects, okay? So we need some new ways to think about the way these things work. So one thing that we need to make sure of that we're doing is that the properties of numbers still hold for the way we interpret these operations with fractions. In other words, multiplication still has to be commutative. We still have to have 1 as the multiplicative identity. All those things have to stay. If those things aren't working out, then our interpretation is wrong. Fractions have to behave like numbers behave. Okay, so we'll start with some easy stuff here. Now, one thing that you should be thinking about, whenever you see times in this context, think of the word of. Of. Okay, this, I didn't really count off for this on the quiz, but in that, on that last question, we had something like Anne ate 1/3 of the cake. Her brother ate 1/2. What fraction did they eat together? We really should say they ate 5/6 of the cake together, okay? 5/6 of something, because these fractions are kind of relative. Okay, so let's start out easy. Okay, so something like this. One half times 1/3. So what we're thinking of is we're thinking of 1/2 of 1/3. And we can model that something like this. What I do is I get a model for 1/3. Okay, so there's my model for 1/3. Now I want 1/2 of this. Okay, so what I would do is I cut this into 2 pieces. In fact, I'll even use another color here. I cut this into 2 pieces, and I take one of those 2 pieces. Okay, so 1/2 of 1/3 would give me 1/6. Okay, because when I do this, if I take my original rectangle, cut it into 3 pieces, well, that whole piece is 1/3. I want half of that. Well, now there are 6 pieces. If I cut the whole thing in half, I got one of those 6 pieces, so 1/6. Okay, now what we should do is we should make sure we can switch the order and still get the same answer. So 1/3 of 1/2 should give me the same thing. So let's think about this. So I would do a picture like this. Okay, 1/3 of 1/2. So I'm starting with that. So I'm going to start with the model for 1/2. Now, what am I going to do with this picture? Remember, 1/3 of 1/2. So I start with a picture of this, and what do I do with it in this case? Cut it into 3 pieces, okay? 3 equal pieces. and then we're going to take one of those. So the result is still 1/6. Okay, now the reason I'm taking 1 here, of course, is because 1/3 of this piece over here. Okay, so in this case, what I did was I started with a model for 1/3, and I cut that into 2 pieces. Okay, start with this, and this tells you how many pieces you're going to cut that picture into. Okay. So here's what I want you to do in your seats here. I want you to come up with a model for 2/3 times 4/5. Okay? I want you to create an area model for 2/3 times 4/5. Take a second in your seats, see what you can do. So remember, we're thinking about of. So 2/3 of 4/5. So we could start with a picture that represents 4/5. Start with that picture, and then what do we do with that picture? Picture representing 4/5, and then we're going to do something to that picture. What do we do? Okay, so I'm starting with my rectangle here like such. So how many pieces should I cut this into, and how many of those pieces should I shade? Okay, 5 pieces. Why are we cutting it into 5 pieces? Right, because we're dealing with fifths. Okay, this tells us the number of pieces to start with. And then I shade 1, 2, 3, 4 pieces. Okay? Now, how many pieces should I cut this into? Hmm? 3 pieces. Okay. So, once again, I'll go to a slightly different color. So we got 3 pieces. 1, 2, and then of course 3, right? So you do need to make a careful distinction between the number of cuts and the number of pieces, right? You want to cut something into 3 pieces, you got to do 2 cuts. If you do 3 cuts, then you'll make 4 pieces, which isn't what we want, okay? So now, how many of these should I take? So I got these guys down here. How many columns should I take? I mean, before I just took 1. Do I just take one of these pieces and get 1/15? Okay, 2 of the entire columns, okay? So I should be taking this entire thing and this entire thing. Okay, so we're wanting what's double shaded. Okay, so how many pieces are there altogether in this new picture? 15 pieces altogether, right? Because we have 1, 2, 3, 4, 5 rows and 3 columns. So that's 15 total pieces. And how many pieces are double shaded? 8 pieces are double shaded. Okay, so this tells us what to start with. This tells us how many cuts to make, or how many new pieces to make. And this tells us how many of those columns to shade. Okay, so 8/15. Okay, so what's the rule when we're multiplying fractions? This should be illustrating the general principle of what to do when we have one fraction times another fraction. So how do we find the product? Okay, right, we multiply the top and the bottom kind of independently there. Okay, so 2 times 4, we have 8. 3 times 5, we have 15. Okay, so the total number of pieces came from the cuts. Okay, we cut into 5 pieces, and then we cut into 3 pieces the other way. So the total number of pieces came from the cuts. The total number of double shaded pieces came from the tops. Okay, we initially shaded 4 of the 5, and then we shade 2 out of the 3 of those chunks that we made. So this is AC over BD. Okay, fractions are very easy to multiply. Multiply straight across. They're more difficult to add. What do you have to do if you're going to add fractions? Right, you have to find a common denominator before you can add fractions. Okay, so multiplication with fractions, very easy. Okay. So let's go ahead and talk a little bit about some word problems. Involving these fractions. So let's do this. Let's say a road is constructed at 1/2 miles per week. Okay. So they're building a road out there. The crew can make 1/2 mile of road every week. Let's try to answer this question. How many weeks are needed to build 1 3/4 miles of road? Okay. So what are we going to have to do to answer this question? Okay, we're going to need to divide, okay? If you need a similar problem, let's say they could do 2 miles a week, and we asked how long to build 6 miles of road, okay? Now it's pretty clear, okay? Every week you go through 2 miles of road, you want to get to 6 miles. You do 2 divided by 3, 3 weeks to get 6 miles, okay? We just have different numbers. It's the exact same problem structurally. We just have different numbers. So what we're wanting to do is we're wanting to take the distance that we have to cover and divide by the rate at which we cover that distance. So we're going to take 1 3/4 miles, and we are going to try and figure out how many pieces of a half we need to make that happen. Okay, so what we got is this. Here's our diagram. So my total length that I need to cover is 1 3/4 miles. That's a half, that's a half. I don't know how many pieces I'm going to need, but I'm going to be doing that. Okay. So, what kind of division interpretation is this? Because we had 2. Think back to the division chapter. We had 2 ways to think about division. Okay, this is measurement. What was the other one called? Started with a P. Partitive. Okay, now, what was the key thing to tell us we were dealing with partitive? It's kind of in the name. Right, part. Partitive was asking how big is the part? Well, here we know how big the part is. You build 1/2 mile of road per week. That's the part that you do each week. The question is, how many parts are there? Okay, so this is measurement interpretation. Okay. Okay. So let's think about this here. We want to do 1 3/4, okay? So I'm thinking about taking 1/2 and kind of adding it to itself until I get 3/4. Okay, so this is the first week, right? And this is kind of what my teacher's solution is going to start to look like. So 1/2. Okay, do I need to do any more here? What do I need to do? Can I stop? I should keep going, okay, because I haven't gotten 1 3/4 yet. Okay, so that's the first week. Here's another week. Do I keep going? Okay, I keep going. Okay, now do I do another one? But can I stop? How much road do I have right now? I have 1.5 miles, okay? So 1/2 mile corresponds to 1 week. So I need 3 weeks, but I can't stop, but I don't go for another week. What do I do?
Do you take half of a half?
Right, okay, I go for half a week, okay? So if I did 1/2 of a week, that would give me 1/4 mile of road. So that's that extra right there. 1/4. That gets me to 1 3/4 miles. Okay, so it will take 3½ weeks. Okay, so that's an example word problem using a measurement model for division, right? So we talked about how to multiply fractions. You multiply straight across. We need to come up with a way to make sense of dividing fractions, okay? Because we have to do all the arithmetic operations with fractions, just like we do with whole numbers. And the goal is to come up with some kind of justification, okay, some kind of justification for the invert and multiply rule that we have for dealing with fractions. Okay, so let's look at example 2 here. Here's another example. If 1/2 of a jump rope measures 1 3/4 of a meter, what is the length of the whole rope? Okay, so we still got the same two numbers involved. We got 1/2 and we got 1 3/4. But this is a slightly different interpretation of the thing right here. Okay, so in this first problem, we were saying 1 3/4 is how many halves? Okay, the question is, how many of these bars do I need to complete the length 1 3/4? How many of these bars, length 1/2, do I need to figure this out? And down here we saw it's 3 1/2 of those bars. Now this is a little bit different. So what's the difference? What's the kind of question that I'm asking? Add what? Okay, so you add 1 3/4 to itself, okay? So what we're really asking in a way is we're saying 1 3/4 is half of what? Okay, so we're trying to figure that out. So we have this whole length here. The 1 3/4 corresponds to this, and the question we're trying to figure out is what is the entire length? Okay? So 1 unit equals 1 3/4 of a meter. So what is 2 units equal to? 3½ meters. Okay, so in other words, we've got this interpretation of division right here. Okay, so you can think of it as a division word problem. And it shows that when we're dividing by a half, that's equivalent to multiplying by 2. Okay, the invert and multiply rule. Okay. So, a couple of things here. Back over here, I want you to make sure, so when you're looking at this in your notes here, compare this to pages 49 to 52 of Primary Math 5A. Okay, so make sure you look that over when we're talking about this area model for multiplying fractions. So make sure you have that down. And if you haven't already done this, carefully go through section 6.3 of your textbook, Elementary Math for Teachers. Okay. So the next topic that we're going to cover is going to be dividing fractions. Okay. So the goal is this invert and multiply rule. Okay. And we must, as teachers, we must be able to explain the concept. Okay, so we've got to explain what division by fractions means and why it works. Using models and word problems. Okay? So we'll do a quick review here. So reviewing a whole number divided by a whole number. Okay, what's this about? Before we get to fraction divided by fraction. Okay, we'll look at various cases. Okay. So two girls share 5 cookies equally. How much should each get? Okay, so the first thing I want to do is classify this. Is this a measurement division problem or a partitive division problem? Okay, partitive. How'd you pick that out so quick? Okay, so there's 2 of them, right? So we have 2 kind of collections. We're going to break whatever we have into 2 parts. 2 girls sharing the cookies. Now the question is, Well, what do we have? We have 5 cookies. 1, 2, 3, 4, 5. Okay. So I could do it this way, right? 1, 2, 3, 4, 5 cookies. I've broken the 5 cookies into 2 equal parts. Okay, I've got this part, and then I've got this other part. So 5 divided by 2 is equal to what? Say again? 2 1/2, okay? Now what if I said this? What if I said, okay, I'm going to divide it differently. I got my 5 cookies here. I'm going to divide it into 2 equal parts by doing this. Okay, so 5 divided by 2 means 5 half cookies. Okay, and 5 half cookies, that means 5 times half a cookie, right? Because you have that, plus that, plus that, plus that, plus that. So 5 halves. Are these 2 different answers? Okay, why not?
Because 5 halves is technically 2.5, which is 2.5.
Okay, right. How do we convert between these 2?
Long division.
Okay, here we could do a long division. Take 2 divided into 5. Okay, it goes in 2 times, there's 1 left over. So the mixed number corresponding to this improper fraction is 2.5. Okay, so this is something we talked about earlier in the fraction section, converting between improper fractions and mixed numbers. And if you do that here, if you take this if you take this mixed number and convert to an improper fraction, you would do 2 times 2 is 4, plus the 1 is 5. So this is 5 halves. Okay, so they are the same number. And we could do that. And we could show that using the techniques that we had discussed before. Okay, so we are going to continue dealing with division until we eventually get to fraction divided by fraction. Okay.